So when we have centroids, what do we know about centroids? Remember, AG over GM was what?
2 to 1.
Exactly. We know something. And length of medians, all these things. PG squared, do you not remember PG squared was what?
What is P?
P was any point, any arbitrary point, and G was centroid. Have I told you this before?
From any point? No, I don't
Yes,
remember
P
this.
can be any point. It's 1/3 of PA squared plus PB squared plus PC squared minus 1 over 9A squared plus. Have I told you this before?
No.
Okay, after this problem, we will prove this. There are some ideas, some formulas about centroids, so let's apply. Let's check this one. It says ABCD convex quadrilateral. Centroids of 3 of the triangles 4. The vertices of an equilateral triangle. What's the maximum possible value of the area? Okay, A, B, C, 2. If we consider something like this. Let me take this one. Okay, so it is C. This one is E. This one is B. This one is A. It is 2. It is 6. Centroids of A, B, C. Okay, let's check. All of them that are related to C. ABC, CBD, ADC. So all 3 triangles that are related to C form versions of equilateral triangle. Okay. So can you tell me what's the property of these 3 centroids is good to consider what?
Property of these 3 centroids.
We should draw which new line. If you want to draw all medians, then we have lots of lines, right? And it's
Yeah.
hard to work. So we can only draw which medians.
I don't know which median is good to draw.
Look, which medians have a common point?
I mean, A, B, C, B, C, D. No. I mean, maybe from B.
From
draw
B?
both medians.
But look, ACD doesn't have B.
Or C.
Exactly. Connect C. All centroids lie on medians of C, right?
Yeah.
You can connect these 3 lines, right?
Mm-hmm.
And the centroids are on this line, and we know the ratio is 2 to 1, right?
Yeah.
So for each of them, we connect 2 to 1. And because here, consider 2 to 1, here it says it is an equilateral triangle, right?
Yeah.
Now we want to see if here we have equilateral triangle, if we connect these 3, again, they are equilateral or not. Understood what I mean?
Wait, what?
Look, it is, for example, M, N, L. This one is G1, G2, G3, right?
Mm-hmm.
Then we know G1, G2, G3 is an equilateral triangle, right?
Yes.
Triangle. We want to see, can we prove that from these that M and L also is an equilateral triangle or not, okay?
Okay.
So try to see it's correct or not. If it's correct, try to prove it, okay? M and L are midpoints of these 2 sides and this diagonal, okay?
Yeah.
So try to...
Wait, but M and L is just a homotopy of G1, G2, G3 around C.
Exactly. Yes. So, and also we can say this one is parallel G1. G2, we know is parallel to MN, right?
Yeah.
Because all three sides are parallel, so the angles are same, so again 60 degrees, right?
Yeah.
Okay, now we can remove centroids, and it is so much easier to work with if you work only with midpoints, right?
Maybe. Yeah.
Yes, because what G was a point intersection of medians, and we should draw medians, but here we don't need to draw new lines. It is only midpoints of the two sides and the diagonal, this diagonal, right?
Mm-hmm.
Okay, this one is equal to this one is equal to this one. We know CD is 6, BC is 2, and also this one, 1, 2, 3 is equal to this. So now we know NLM is equilateral triangle, right?
Yeah.
So by using NLM, all angles are 60, all of them are equal, so try to find maximum area. Try
Let's see.
C by C.
I mean, I just made like a function. I set BCD to theta, and then I wrote the area as a function of theta, and I just took the derivative, and I got C.
So you found the area in terms of theta.
Yeah.
So the area of ABD in terms of theta is what?
So first I find so first I know ABD is an equilateral triangle,
Ah, exactly. Because
and then
this one is similar, okay? So
I
this is
find
length
BD.
is A, this length is A, this length is A. Then what?
So so BD squared I wrote it as 40 minus 2 times 2 times 6 cosine theta. So it's log. And
BD
then I
squared is what? Can you say it again? Ah, is
40
4
minus
plus 36, 40 minus 4 times 6, 24 cos theta. Then what?
then times square root of 3 over 4 is the area of ABD.
Okay, so A squared root 3 over 4, or we can say BD squared root 3 over 4, 40 minus 24 cos theta times root 3 over 4 is this area plus 6
Plus 2
sine
times,
theta.
yeah, 6 sine theta.
Then what?
And I just take the derivative.
Okay, so if we take the derivative, so here 40, 10, 6. So it is f of theta. F prime is what?
F prime is 6 cosine theta plus 6 root 3 sine theta.
6 root 3 sine theta plus 6 cosine theta is 0. Then we can say what? We can divide both sides by 6.
You can say tangent theta equals negative 1 over root 3. So theta is 5 over 6. 5 pi over 6.
3 over 3. We know tangent 30 is 1 over root 3, so it's tan 150 or 5 pi over 6, right?
Yeah.
Okay, so here you can plug in, right? We can
Yeah.
say
And I
f
go
of
back to the
150 degree equal to 10 minus 6. Cosine 150 is what?
cosine 150 is negative root 3 over 2.
Root 3 sine theta is what?
1 half.
Exactly. Okay, so it will be 10. Root 3 is 3. 6 over 2 is 3. So we can say 10 plus 9, right?
Yeah.
Plus 3. Let's check it out. Sorry, 10 root 3 plus 9 plus 6. So it would be 12 plus 10 root. Okay, choice C. Good job.